All right, linear equations, lesson 1, 2, video number 2. All right, here's our first question. Use linear equations to solve problems. 4 friends use an online code to get discounts on concert tickets. They spent $312 for the 4 tickets. What was the price of one ticket without the discount? All right, so if we take a look at this situation here, right? So we're ordering tickets for a concert. If you've never done that before, if you go online, usually they have the venues map like up here with the A's, B's, and C's, and you pick your ticket. So here's what they did. They bought 4 tickets for the price we don't know. That's what we're trying to find, right? So this is going to be our X. So the price is going to be our X. And again, they got a discount of $15 per ticket. So this is their discount. And their total was $312. So we're trying to figure out what was the original price. So if we take the $4 and we multiply it by the original price, that would be the original amount they spent for all the tickets. But now we're going to subtract the discount. 4 at $15 each. That's going to leave us with the amount they paid, which is $312. Okay, so now we're going to solve this. Now, I'm going to simplify the 4 times 15. So 4x minus 4 times 15 is 60. Minus 60 equals 312. And again, 2 steps. X is being multiplied by 4 and subtracted by 60. So undo it, reverse. Add 60. So 4x equals 312 plus 60. 2 and 0 is 2. 6 and 1 is 7. There's no 1 to carry. And then the 3 just comes down, 372. And now we're going to divide both sides by 4. X equals 4 does not go into 3, but 4 goes into 37 9 times. That's 36, right? 37 minus 36 is 1. So now you have a 12. 4 goes into 12 3 times, right? Just throwing out some mental math for those who need reminded. And there you go. What was the price of one ticket without the discount? $93. There we go. Nice. Okay, I only got one more problem, and then this section is done. Awesome. All right, another word problem. I love these word problems. Here we go. Solve work and time problems. It says LaTanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. Oh, bummer, right? She expects to wait 30 minutes for the repair. Then she will ride her bike home. Yes. Can she be home in 1 hour? So a couple things, all right? So we have this trip, right, from home to the bike shop. So that's in orange, right? She's walking, right? So this is her. So we're going to walk this way. That's the first part. Then up here, we're going to wait. All right, we're going to wait at the bike shop. And it says we're going to wait 30 minutes. But notice here that it asks for, will she be home in 1 hour, right? So, a couple things. We can change all of this in terms of hours. And it looks like here we have these rates in terms of hours. So let's go do that. So 30 minutes is just a half hour, 0.5 hours. So her wait time is 0.5 hours. And then she comes all the way back using the blue, right? This is her pathway back. This is the second pathway. And again, at 10 miles per hour. All right, so this is going to be a version of rate times time equals distance. This is your velocity formula from physical science, if you took that. Now, we are focused on time, right? 1 hour. So what I'm going to do is I'm going to solve this for time by dividing both sides by r. R's cancel, t equals, d over r doesn't simplify, d over r. So we need to talk about total time because there's 3 times that are going to go into this. So there's time 1, time 2, time 3. Oh, here's what I did. Sorry, I did this. I said, okay. So I called time 1. I called time 1 home to bike. So we have the time from home to bike. Then we have the time that she waited. Then we have the time from bike to home. And that's going to equal the total time. All right. So all of these are going to be a d over r, the distance she traveled divided by the rate at which she's going. All right. So from home to the bike shop, she traveled a distance of 1.5 miles, and she walked at a pace of 3 miles per hour. Then she waited a half hour. So that's just a straight time. No need to do a distance and a rate. And then on her way back, she also had to go 100 or 1.5 miles, but now she's riding at 10 miles per hour because of her bike. And this is going to equal our total time. So however you want to do this is fine by me. You could type all this in at once because it's all numbers. I think I did it individually. So I got 0.5 plus 0.5, and then 1.5 divided by 10 is 0.15. That's going to be the total time. If you add that up, that is 1.15 is equal to the total time. So that means it took her 1.15 hours to do this trip. Well, 1.15 hours is more than 1 hour. So no, she did not get all this done within an hour. Okay, she cannot be home within an hour. No. Okay. So again, this is our main answer, no. All right, so hopefully that made sense, and you enjoy the different kind of word problems. Fun times. Again, linear equations, things you've done in the past. Promise. All right, thanks for watching, and we'll see you next time.